Hi, I'm Ehsan, and I'm going to show you how to calculate the work function of a material. In the first video, I show you how to build a slab, and when we have a slab, we start the ab initio calculations with VASP, for example. And two important points in the input file is that you need the local potential to be written with this tag LVHAR equals true, which writes the Hartree potential to a file. The second important thing is that you turn the dipole correction on with this tag LDIPole is true, and the direction of the dipole correction should be across the third in the Z axis, for example, because our slab is in the Z direction, the direction of the surface, I mean. And don't use an electric field here. It can be zero, so it's not actually necessary here. And use the switch the symmetry to zero also. And after doing the calculations, you get a log path file, which is what we are going to use to visualize the potential. Using the logpath file in Vesta gives you this file, and we need a line profile here. So we go to utilities and line profile, and we select the start and the end of a line because this is the points that a line is going to be drawn, and accordingly the local potential be extracted in on this line. So after doing this and saving the file, you get a text file which is this format, and then you copy these data into Excel, and you get a curve like this. So what is important here? The only parameters that we need in this curve is the potential of the vacuum layer. Yeah, this is the direction, and these are the atoms, and this is the vacuum above the slab, and its potential is around 1.61. So we write the potential. This is vacuum. So the definition of the work function is the energy needed to remove an atom from Fermi level to vacuum. We have vacuum here. We also need Fermi level energy. So where can we find it? It's in the outcar file. If you find Fermi, you get some values. Use this E Fermi is minus 1 point something, and I've written it here. This is actually for lithium 110 orientation, and you should keep in mind that every plane can have different work function, and the value that is measured experimentally is kind of an average over the values depending on the texture and the orientation of the bulk material that you're having. So if you subtract the Fermi level from vacuum, you get the work function of the material, which in VASP units it's in electron volt.